Hello everyone, today we're going to be predicting categories of expenses. So this will be a two-part build from the scratch video that will first build us a pre-trained LLM, so similar to a very basic chat GPT kind of thing that will be completing our expenses sequences, and the part 2 will effectively try and predict the type of expense that our miniature chat GPT will be auto completing. So if you look here, I've got my Google Colab that performs these two steps. So we have several categories of expenses: travel expense, meals, cloud hosting, software, tax payable, office rent, fuel, and accommodation. And we will effectively be using these categories for our task. So just to kind of quickly show you an example, first we build this kind of a fictitious data set with these columns: date, vendor, description, amount, currency, and label. Right, so that's what we will be predicting in our part 2 based on this sort of information. Then we're going to build our random data set here, and we'll create these rows this way. Then we're going to build our text data set, but we'll be representing it in bytes. So instead of words, we will be rather using tokens for, bytes as tokens for every single character. So ChatGPT obviously predicts the next word. We will be predicting the next character or the byte. So here is our quick structure of our ChatGPT or miniature ChatGPT, which we'll go over just now. Here we're performing training and calculating the loss, and this is the example. So our part 2 or miniature ChatGPT will be performing task of auto completing or predicting the next sort of set characters. So if we feed it this type of expense, so the date, Uber London, client meeting, travel, here is that piece, then the rest of the sequence will be predicted by our network. So look, not that it just predicts the amount and the currency as we've had in our data set, but it also predicts the type of the expense, and then it carries on into the next row, the next expense even. That's how far it goes. I think that's pretty impressive. So our part 1, which is effectively a miniature chat GPT, will be kind of learning the context that we feed to it, and it carries on and it does it according to our rules, which is the set of rules that we will train our LLM or our miniature chat GPT to abide by, to learn these rules and autocomplete or carry on the sequence in accordance to these rules. So that's part 1. Once that is done, we will kind of build our classifier that will receive this part of the transaction, and it will have to classify it. It will have to assign it the value of whether it's a travel expense, cloud hosting, office rent, or whatever. So part 2 will be slightly simpler. It's going to be kind of basic, but the point here is that we are building a very complicated tool, which will have 2 stages effectively. And like an example here, the part 2 will have this text. So you'll have Uber London taxi to client site, the amount, and the top three, the most probable expense probabilities are, so travel expense is 99% sure that Uber ride, Uber taxi to London would be a travel expense, which is obviously making sense. It's 0% accommodation and 0% software subscription. There we go. The AWS cloud hosting, EC2 compute hours, it's 99 sure it's cloud hosting. So this expense here, Pret a Manger, software subscription, 48%. That's not very accurate. 42% meals entertainment. There we go. We've got our kind of an issue, kind of a mistake, right? But still, number two option is to do with the correct answer. Number one, on the other hand, software subscription. How would it even do that? There's a team lunch piece here. I'm not sure. There, obviously, it's not been trained very well. We probably should tweak the training a bit more. But anyways, these two definitely making sense though. Right, so now that we're done with the demo, let me just quickly walk you through this a bit more. So we importing our dependencies. Here we're kind of presetting categories, right? We want to have to work with these types of vendors, these types of categories, these types of templates here. And we are kind of randomizing it here because we just need to build our training data set, which should be quite large in its size. We're kind of formatting it here as a row, populating this data dictionary for every row. We're going to do a 20,000 rows for this training data set. So obviously the more rows we do, the more accurate the model will have a chance to become, because obviously the larger it just generalizes quite well the larger your data set. So if this data set was in 100,000, it would be brilliant. It would learn patterns a lot better. And we're saving it in the files here. We kind of outputting a little bit of top few rows for us to see. Yes, so and then we start generating the data set here. Pretty much nothing new here. So now the next stage is turning these characters, right, or rows into bytes. So to show you kind of an example here, what we're trying to do is right here. Let me just show you. So kind of if we take this value here, so number 2 would be a certain byte value for that character, then the next 0 will be having its own byte value, just like the ASCII characters would. And that's exactly how we're going to be feeding that data to our neural network. Our neural network does not know what 2 is for, what W is for, and etc. It understands numbers a lot better. So this is what we're trying to do here. So byte value up until 255, from 0 to 255, tokenizer. And this is what we're doing. So we're creating this class here that will perform the conversion from the character into the tensor, which is right here. The next stage here is for us to kind of get the sequence of these bytes. And obviously that will be our training data, and our label will be the same sequence of tokens of bytes, However, the label will be shifted by +1, right? So why is that? Because we're trying to predict the following token. So the way LLMs work is that you give them a few characters and it predicts you the next one, right? So in order to do that, we need to have the full sequence, and in order to show it the label, right, for the training data, we just go one character in front, right? That we actually feeding it the next character that it should be predicting. That's why +1 serves here as the label part. And then obviously we're performing some saving here, and we're showing the length of our training and validation data sets. So they are quite significant in size. Right, so now we're back to our tiny or miniature ChatGPT part. So we're kind of saying that our vocabulary will contain 256 characters. That's for the bytes, 255, which makes sense. So here we're going to have 128 weights, number of heads. So the way transformers or LLMs work is that they have to have several heads for attention. So attention is kind of a special mechanism that uses keys, values, and I can't remember what was the other one. Keys, values, and queries, right? So, and we're doing this simultaneously on several directions. So, Chat GPT 2, I believe, was 96 heads. So, in our case, we're only going to have 8. So, it kind of gives the your LLM, your Chat GPT, to kind of have several parallel ways of analyzing your context, and obviously layers. So we do several attention heads, then multi-perceptron layer behind it. Then obviously there's a level of normalization, and we're doing it in several iterations, therefore allowing our model to kind of allowing tokens to talk to each other and absorb the context, right? So each token absorbs the context and becomes more meaningful, and that's what we're doing here. And so that's kind of really it. We're obviously implementing all of these config parameters within our class. And this is what we're doing here. We're kind of getting our each token gets converted into its own vector. Then we kind of adding position into it, right? So first token would have a position number 1, number 2, and obviously that gets translated into an embedding into a vector. So we're adding these vectors together further up. Then we're building our attention layer, well, actually a head layer with our attention, with our heads, and the feed forward layer as well. And we're stacking them together, obviously. So these are layers that we've just built. We're stacking them in layers, and obviously normalizing it as well. And as a final output, we are outputting our probabilities or logits. Right, so obviously we have to apply the mask to ensure that the earlier tokens do not have access to the later tokens, because they have to be predicting them. They're not allowed to view them. So that's what this piece is doing. Then we're doing a forward pass, and this is kind of, we're effectively stacking everything on top of each other, right? Positional tokens embeddings, applying the mask, performing the actual pass, normalizing it, and obviously outputting logits. Right, so there is that. So yeah, so that's kind of what it's doing here. So the next stage is pre-train loop here. So uh, I've kind of gone really crazy with the batch size, maximum step, and evaluation iterations. And so the way I did it is I've kind of pretty much maximized my A100 RAM. Um, so I think this neural network, whilst training, it's using about 37 gigabytes of virtual RAM on my A100 GPU, which is significant. Yes, and here I'm performing optimization and evaluating loss, which is pretty standard. Yeah, so this is my training loop here, nothing special here. And yeah, so we're performing training, outputting the graph with how the loss kind of gets. Well, you can see that my GPU was really wasting time after 500 steps, because it was more or less optimized at this point. Yes, so that is us testing it here. I believe I showed this example, so we were feeding this to the neural network, and then that was the prediction, and it kind of looks impressive. And then once that is done, we are using this to feed this into the classifier, which is effectively how we're doing it. So we're providing the x, which is the inputs into the model, which is effectively those parameters, and then we're providing, we're predicting we're using our LLM model or miniature chat GPT to predict the type of the expense, and the model effectively adjusts its weights to learn from this, and it kind of learns how to assign categories and how to categorize the transaction, the expense. Sorry. Yeah, so nothing special here really. Is there anything here I should bring up? Nothing that springs to mind immediately. It's all pretty standard. So yes, so here is the model class, expense head. So we are effectively just using a normal linear level layer with, that's how many, that's the features coming in, and that's the classes coming out. So yeah, it's all done just in one layer. Yeah, and we are effectively checking for accuracy here, and calculating loss, and that is our training loop here. So quite standard. In terms of confusion matrix we're building, that is all set here, and that is our matrix. So in terms of confusion matrix, so if a column contains a lot of rows with value, that is effectively meaning that the model does a lot of over prediction, and it's not the case here with our model. And obviously rows containing the values, so for instance if these values were all filled out for the fuel, that would effectively mean that the model gets really confused on what the fuel is, and that would mean that it's really difficult to predict fuel for the model. But because it's a straightforward example, and we've used a really clean data set that we've synthetically generated. It looks like our data was quite good, so there's hardly any confusion there. It's borderline perfect. Right, and that is just a little demo that I believe I've gone over previously. So yes. So here is a really simple, really basic boilerplate example on how to train LLMs, what they represent, how they could be used in finance. So to summarize everything, we've used LLMs to contribute to a task of classifying expenses, which is something that we'd like to do in finance, accounting, or tax. And this is how it could be used. So if your company contains a lot of information in its databases on the transactions or journals or expenses that your company is using, how it's been using them, this would be a really good example or a use case on how to build your own proprietary neural network that will be doing the auto-completion or classification of transactions. So I hope this example was really productive, was really useful for your team, for your company, and I hope that you would have the chance to share your thoughts on the validity of this network, of this neural network, and potentially drop a few suggestions on how we could tackle another use case. Maybe you have a really good suggestion for your company, for your industry. I'll be very excited to hear and try and tackle it in the future. Thank you so much. Thank you for your time. As always, very grateful. Cheers.